In this video, we're going to just get some practice on solving some word problems that require right triangle trigonometry. As a quick reminder, in right triangle trigonometry, we will repeatedly use this mnemonic device, so, ka, toa. So stands for the sine of an angle is equal to the opposite leg divided by the hypotenuse. Ka stands for the cosine of an acute angle in a right triangle is equal to the adjacent leg divided by the hypotenuse. And toa stands for the tangent of an acute angle in a right triangle is equal to the opposite leg divided by the adjacent leg. So let's dive right in, see what we've got. Here's our first problem. You want to work on the roof of your house. You know that you have a 20-foot ladder and the roof of your house is 17 feet above ground. You want to find the smallest angle, so find the angle your ladder can form with the ground in order to reach the roof to ensure your ladder is safe for your house. What is the measure of this angle? Okay, so basically, I'll draw a house and a roof, or sorry, a house and a ladder. So there's our house. Isn't it lovely? Here is a ladder. Isn't it lovely? Don't ask me why it's getting wider at the bottom. It's that type of ladder. Okay. And basically what we have is this. We have a right triangle. Now, this can actually be a very important question because if I lean a ladder, so here's my wall. If I lean a ladder against the wall and the ladder's like this, and you try to climb that ladder, it could fall backwards, you could hurt yourself. If I lean the ladder against the wall like this, and I try to climb this ladder, the ladder could slide down and you could hurt yourself. So there are actually, I mean, if you ran a business, worked for a company, there are actual safety regulations on what size ladders need to be used for what types of jobs. Now, if it's your own house, do what you want, just try to be safe. But it is a real problem. So let's figure out how to solve this problem. We know that we have a 20-foot ladder. Well, where's the ladder? The ladder's right here. Put a 20 right there. I'm going to assume your house isn't all tippy, so I'll put a right angle there. And we know that the roof is 17 feet above the ground, so I'll put a 17 here. I want to find the angle the ladder makes to the ground. That's going to be right here. I'll put an X right there. So now I go through and do some trigonometry. Across from that is hypotenuse. Across from that is opposite. Next to this is adjacent, which is unnecessary for this problem. I have O, I have H, I have an angle. When I look at so, ka, toa, I know that the sine of my angle, sine of x, will equal opposite over hypotenuse, 17 over 20. Now, this is actually one of our great quick answers. I just do the inverse sine of both sides because I need to get rid of sine. So x is equal to the inverse sine of 17 over 20. I go to my calculator. I type in 17 over 20. I look for my inverse sine. It's not here right now. Press the second button. There it is. And the inverse sine, well, let me press equals on that, 0.85. Inverse sine of that is 58.213 degrees. So x is approximately 58.213 degrees. Now, this is pretty far from the base, pretty shallow angle. I would be a little concerned about it slipping if I set it up that way. Okay, next problem. You need to go from your house to the nearest park. So here's your house. Let's see. To get there, you walk at a 25 trajectory east of due north. So let me make your house smaller, and the park's over here. So basically what's happening is this. We have our standard cardinal directions. We have north, east, south, and west. And so you know that to get from your house to the park, you're going to travel a little bit east of due north. Okay. And you know that if you walk 800 meters, that'll get you there. You have a silly, stubborn friend who refuses to walk any direction that is not a cardinal direction. So your friend will only walk north, east, south, or west. I don't know why he's your friend, but all right. So how far north will your friend have to walk before turning east? So basically, I need to figure out, so I can tell my friend how to get to the park, how far north this needs to go. And let's see, 25 east of true north, so that's going to be 25 degrees right there. I have my right triangle. I'll do a little bit of trig on it. So I have my angle. Here's the hypotenuse. There's the opposite. There's the adjacent. I have the adjacent and the hypotenuse using so, ka, toa. A and h is that. So I will do the cosine of 25 degrees is adjacent over hypotenuse, so x over 800. I'll go to my calculator. I need the cosine of 25 degrees. So 25. Right now I'm setting inverse cosine, so let me change that back. Cosine. Okay, I get 0.90631. And that's going to be approximately x over 800. I will set up a little proportion. I will cross multiply. 1 times x gives me x. 800 times 0.90831. So times 800 gives me 725.046. So 725.046. And these are in meters, so I put a little meters on that. Okay, next problem. You have decided to emulate your hero, Benjamin Franklin. Now, spoilers, don't fly kites in storms. But let's see what you're doing in this problem. You want to fly a kite to study electricity. Okay. You want to get your kite 1,000 feet into the air. You know that the 1,000 feet. Okay. You know that the angle of elevation of the kite string is 40 degrees. How much string do you need to let out to get your kite to the appropriate level? So, you're here. Kite's here. We are letting out string. Do we know how much string we're letting out? Nope. It says how much string, so put a little X on there. I'll draw the rest of the right triangle so I can apply my trigonometry. I know I want it 1,000 feet into the air, so that's going to be up 1,000 feet. I know that the angle of elevation is 40 degrees, so that's 40 degrees right here. Again, off the horizontal, not off the vertical. I'll mark up my triangle, so that's the hypotenuse, that's the opposite, this is the adjacent. I have H, I have O, using so, ka, toa. Let me try that again. Let me try to write again. So, ka, toa. I have O and H, so that lets me know I'm going to be doing the sine of 40 degrees is equal to opposite over hypotenuse, 1,000 over x. I'll go to my calculator. I'll do the sine of 40, so I notice I'm doing the normal sine, not the inverse sine. I get 0.64279. To solve this, I'll set up a proportion and cross multiply. So I get approximately 0.64279x is 1,000. Divide both sides by 0.64279. Okay, 1,000 divided by 0.64279. And I get about 1,555.718. And that's in feet. And as a little check, it should make sense that this is longer than that. You can see this side is longer than that. Okay, one more example. You want to build some shelves that lean against the wall. And then, fun note, I actually had to do work like this when I built my shelves that lean against my walls in my house. So I want the shelves to be 1 foot wide, 5 feet tall, and I want to know what angle they need so that they don't look all janky down here. You know, I don't want shelves that look like this. I want shelves that look like this, where it will lie flat on the floor. So I need this angle. So real problem. Okay, well, it's actually pretty quick and easy. Once you realize this is the shape, it's just a right triangle, I'll put my unknown right there. I need this angle, and I'll label my triangle. Across from the 90-degree angle is my hypotenuse. Across from my given angle is the opposite. Next to that is adjacent. I have the opposite and the adjacent. So I look at toa. That one has opposite and adjacent. I will do tangent of x is equal to 5 over 1. I'll go to my calculator. I'll do, actually, let me write the next step. Sorry. X is equal to inverse tangent of 5 over 1. I got ahead of myself there. Now I'll go to my calculator. Do 5 divided by 1. Big surprise, it's 5. And then I'll do the inverse tangent of that, so second tangent. And I get about 78.690 degrees. So x is approximately 78.690 degrees. Okay, again, there's a link to the original video down below and a link to the attached worksheet so you get some more practice.